everyone. Good afternoon. I am Archuk Sadhu Khan. I am a PhD scholar from Kalyani Government Engineering College, and Dr. Shiv Shankar Saha and Dr. Pritam Kumar Gain are my guides. So my field of my research work is to develop a 3-port converter, which is a solar and battery integrated converter to supply the load or inverters, I think. So, the content of this presentation are shown here. The first, we will discuss the circuit diagram of the dual input full bridge converter, which is DI-FBC converter. Then I go for timing diagram and the circuit operation. Then I show the mathematical analysis. Then I show the ZVS region and the experimental setup and result. So first of all, we need to know what is ZVS. So ZVS is certain features of power electronics converter. So it enables the converter to operate at a more high frequency, so that the component size got reduced. Component size means the energy storing element like inductors and capacitors. In my topology, this topology I'm working in this topology. Here is my SPB panel. So 1 minute. Here is my SPV module, the solar module, and here is my battery. So this is my topology actually. This is the full bridge topology, consisting of both half bridge, where the solar panel is one side and battery is other side, and the load is here. Okay, so battery will sink source excess power, whether solar panel, when the solar panel produce more power, battery will sink the excess power, and when the solar panel is not capable to supply the load, the battery will supply the excess. The battery will supply the rest of the power to the load. Okay. So in this work, I have only concentrate on the zero voltage switching, which is named as ZVS operations. So here is my timing diagram. So the gate pulses are switch SA1, SA2, and switch B1 and switch B2. Of this leg switch SA1 and switch SA2, switch SB1 and switch SB2. So all of the current and the voltage of the switches are shown in here. Here we can see the transformer current, the transformer in here. We can see here transformer current. Here the switch current and the switch voltage of each switches, and we can analyze the ZVS region by observing the timing. By observing the timing instant, timing instant of the operation, we can define the equations of each and every segment, where I describe in my paper. So the timing in this timing sequence, the operating mode of the switches are going from this to this. Okay. So the condition for the ZVS operation is shown here, which is ultimate condition which is defined from the timing equations. And here we can see the switch current should be greater than 0, and switch the energy stored in the inductor should be greater than the energy stored in the capacitor. Okay, switch current should be greater than 0, and switch current should be greater than this term. So we can achieve the ZVS in this case. So here is the, these are my ZVS regional graph, which is analyzed in the MATLAB software. And the switch S1 and switch SA2, switch SB1 and switch SB2 are the 4 switches. And here is the ultimate, the ZVS region of my total circuit. So circuit will operate in this section only, circuit will operate efficiently in this section only, the pink section. Okay, so I have done my experiment in our lab. This instrument I used this instrument, the power supply, the battery emulator, the solar emulator, and the load emulator, which is electronic load. And this is my oscilloscope. Here is the 3-port converter prototype. Okay, and here is the controller. We obtained these switching diagram from my experiment. Here we can see this performing as expected as I analyzed in the theory. Okay, so switch SA1, this graph is for switch SA1, this graph is for switch SA2, this graph is for switch B1, and this graph is for switch B2. So I can conclude my the analysis I have done in my theoretical work, and the experimental work is perfectly matched as my expectation. So the soft switching behavior I have found is very desired, and the zone I have obtained in my analytical performance, the zone are very much very matching with my experimental result. Okay, so this is my presentation and this is my work. Okay, thank you. So anybody have
for this wonderful presentation?
Okay.
So nice work actually with respect to experimentation and theoretical validation and all.
Yes.
Nice efforts by you. Thank you. Well, I will go ahead with the next presenter for the day. I call upon now Sudeep Das. Do we have Sudeep Das?
Yes, sir. Yes, sir. May I audible?
Yeah, please share your presentation. Yes, you're audible. Please share your presentation.
Yes, sir.
Yeah, Archan, request you to stop share screen. Archan,
Yes,
can you stop share screen?
Hello, this is visible?
Yes, yes, it is visible. Please go ahead. Thank you.
Okay, okay. So good afternoon to all presented dignitaries. It is my great opportunity to present my paper. Myself, Mr. Sudeep Das, PhD scholar, NACOUT. So my topic is intent. Can is visible, sir? Hello, may I audible, sir?
Yes, you are audible. Please go ahead.
Yes, yes, yes. Okay. So what are the motivation behind this project? Actually, the project is we have you are all see there have a data collected in the year 2018, that is the solar PV installation around the world. So in here we can see that India is in the 5th position, but you can also see another part, that the growth of the PV capacity. So this is in the growth, we can see that is the 2nd position in the world. So the huge opportunities in the solar sector. So, and another motivation from my work is the extrapotential solar radiation is 1367 watt per square meter. So huge amount of wattage or power that are reflected in the solar atmosphere, in the Earth atmosphere, and the maximum efficiency achieved 46%, and this is day to day this achieved efficiency is increased. So this is the huge opportunity to us to improve that efficiency and get the optimum power from solar energy. So the abstract of the project. So develop a new and efficient algorithm for the extraction of power using minimum number of sensors and fast execution capability with easy of maintenance. The second one is the performs well under drastic change in climate as well as in partially shaded condition. This is the most important thing. When the climate is changed, their efficiency will be go down. So we should maintain that efficiency. And third one is comparative study between the conventional method and new proposed method. So in literature survey and in the paper, we have surveyed the different MPPT methods that is already described in several articles. That is, they have a conventional method, soft computing method, and hybrid method. That is actually the combination of conventional and soft computing. So there are some drawbacks in conventional as well as soft computing and hybrid method. So what are the, we have main focus, the piano algorithm and its drawback. And also we focus on incremental conductance algorithm and its drawback. And on that basis, we modify our algorithm. So what are the piano algorithm drawback? Actually, piano algorithm is it is get low efficiency in low radiation. Actually, when the cloud or others obstacle are come, the piano algorithm not work properly. So in this survey or this experiment, we can also identify that, and we find out that modified algorithm. And also incremental conductance algorithm is a complex process, and it have a huge number of sensors. It requires huge number of sensors. So this is the one of the drawback in incremental conductance method, and this is create a noise. If create noise, the efficiency is go down. So what are the software we actually used in this experiment that is mentioned here? All software we choose because this is high accuracy and industry standard. The PSIM professional version and 9.03464 we used, and we are also data analysis, R programming language we used, and we used this solar panel in our experiment. This is the rating of the solar panel for using the simulation. So actually, here we can see one data, that is the intensity versus duty cycle corresponding to MPP. So we get this data from PSIM software and implemented to our programming environment. And we plotted in figure 1, that is in next slide actually. So this curve actually transient response, like a transient response of inductor. So the exponential term on this formula is expected. So this is the plot we get from the R programming, and that is seeing that the near 0.7 that the model is saturated. So near point that we can easily understand this point that the curve is saturated. So the confirmed is the observation. So this is the R environment, and the maximum number of iteration of this model was kept 50. But this model is convert 7 iteration only. We take 50, but it converts 7 iteration only. This is very good convergence ratio, and that the formula is created from this, that the final formula of duty cycle, we can find out that D optimum is equal to AK minus exponential minus B under intensity divided by 1000 plus L into intensity divided by 1000. So these are all the formula generated for a proposed intensity based MPPT algorithm. And this AKBL is the constant for particular this solar panel. And the control circuit, we can found that the sawtooth wave generator, which get is the amplitude is 10 volt. So in the voltage output is given in the comparator is 10 into D optimum. So the total voltage we get from here. So this is the formula that will be generated. And this formula, this algorithm is implemented in piecing. And we get this type of result. So in first slide, you can easily see that is under 92 watt per meter intensity. We can see that is the oscillation near this point. Okay. So this is the we can see the oscillation in here. That is the PNO algorithm. That is the standard conventional algorithm. And this this we can see the oscillation. But in this proposed intensity based MPPT algorithm at 92 watt per meter square, we can see there are no such type of oscillation. So this is react better than comparable to PNO algorithm. But another result we can found that PNO algorithm is work better in high intensity. That is 500, we apply 500 watt per meter square intensity. That PNO algorithm work much better comparatively the previous one. But in our intensity based MPPT algorithm is work much better than PNO algorithm. From this curve, we can easily understand. There have a little bit oscillation in PNO algorithm, but there are no such type of oscillation in proposed intensity based MPPT algorithm. So there have a result and analysis part. So we can apply different type of light intensity, and we observe that the low intensity, that is 92 watt per meter square, we observe PNO algorithm is error is 21%, huge number of error. Comparatively, my proposed MPPT algorithm is 2.2 only, but this rate is little bit similar in 1000 watt per meter square intensity, light intensity. You can observe that PNO 0.33, but my algorithm is 0.84. So that is near about. So from this, we can easily understand that the high intensity PNO work work good, but in low intensity does not work properly. So another result we have observed that we apply a noise. Okay, so we apply a noise in PNO algorithm and get this type of oscillation, huge number of oscillation, but comparatively in our proposed intensity based MPPT algorithm is very little in the oscillation. Comparatively, that comparison easily understand that the our proposed intensity based MPPT work much better in noisy condition. So conclusion. So conclusion is the result presented in previous section clearly shows that for checking the accuracy of maximum power point tracking in low light intensities should be used, and it is clear that significant difference in the percentage of error is observed. But in low light intensity, proposed intensity based MPPT algorithm better perform compared to PNO algorithm. It is also observed at higher light intensity, performance of PNO algorithm improves slowly and steadily, but it is never eliminated. And fourth conclusion of my paper is under noisy conditions, losses are comparatively less and the tracking of the power is considerably better in case of proposed intensity based MPPT algorithm. So these are the references of my paper. Thank you.
Thank you, Sudeep, for your good presentation. Please share your email address. We can connect and people can connect with respect to any queries. We'll quickly go to the next presenter for the day.
Okay.
The time is more. I request everyone to cut short the presentation. Now I call upon Preeti Tyagi. We have Preeti Tyagi.
Yes, sir.
Yeah, please request you to present, ma'am.
Sure, sir.
Yeah, we can see the screen, ma'am. Please go ahead.
Very good afternoon to all. My name is Preeti Tyagi. I'm research scholar at Department of Physical Education and Sports Sciences, University of Delhi. My co-author is Professor Sarita Tyagi. The topic of presentation is relationship between group cohesion, aggression, and locus of control among different sports persons. I'll start with introduction of group cohesion, aggression, and locus of control. Group cohesion is the bond among members of group and degree to which their members are concentrically thrive their effort to achieve the goals of group collectively. It is a dynamic process which has tendency to be united in persuasion of instrumental objective for the satisfaction of members to effective needs. It is also found that high cohesion is related to high group performance, while success in performance increases. However, both social and task have different relation to group performance. Task cohesion indicates that how group or team is as working unit or how it operates, while social cohesion is the attraction among team or the group, or can say the liking towards each other in group. Aggression has been considered as part of sports domain, and it is not only accepted but appreciated in sports setting by large segment of society and spectators. But in few previous years, it has been considered as social problem on and off the field. As we can see, most of the players show aggression on and off the field, which actually leads to downgrade the performance of an athlete. Aggression is defined as infliction of adverse stimulus in any form, which is verbal, physical, or gestural upon one person by the another person. Aggression is a behavioral aspect, and it is reflected in action of the athlete's commitment with the intention to injure the opponent or the team. Locus of control is a psychological concept that refers to how strongly people believe that they have control over the situation and experience that affect their life. Athlete with internal, basically there are two types of locus of control. One is internal and another one is external. So with internal locus of control, generally people believe that their success or failure is the result of the efforts or the hard work they invest in. Athletes with external locus of control generally believe that their success or failure results from the external factors beyond their control, such as luck, fate, circumstances, injustice, bias, or the coaches who are unfamiliar, prejudiced, or unskilled. Now, the research aim is to find if there are any significant relationship between group cohesion, aggression, and locus of control among different sports person or not, to help to get the better understanding and to design the suitable environment for the athletes according to the results. The research methodology is for the study, 600 athletes of different team games, 150 each, handball, football, hockey, and handball, were selected by using random purposive sampling method, age above 18 years from all over the India, who secured nationals medal or at least participated in nationals. And for the present study, three different questionnaires were used. Group cohesion, for the group cohesion, I used AV Karen questionnaire, which consists 18 items with 2 dimensions, that is task and the social, each dimension with 2 components. Social have 2 components, which are individual attraction, group social, which had 5 items, and group interaction social had 4 items. Task have 2 components, which are individual attraction, group task with 4 items, and group integration task with 5 items. It was measured on Likert scale from 1 to 9. 1 indicated strongly disagree, and 9 denoted strongly agree. For the aggression, I used the questionnaire designed by Professor Anand Kumar Srivastav and Prem Kumar Shukla, which had 25 items, and it was in yes or no. Higher the score represents the higher the aggression, lower the score represents the lower the aggression. And the locus of control were designed by Julian Rotter, which has 29 items, and each items had 2 options, A or B, and A and B both had 2 different statements, and the maximum score could be 23. Higher in this questionnaire, it was depicted that higher the score, external the locus of control, lower the score, internal the locus of control. The procedure is, researcher went to different colleges, institutes, camps in order to target the population, and after targeting the population, researcher handed over a packet of questionnaire, which consists pen questionnaire and athlete demographic information. Researcher informed the participants that participation is voluntary. At any point, they can withdraw their consent to fill the form or share the information. After filling the questionnaires, researcher took back the questionnaires. Now for the data analysis, SPSS version 25.0 were used, and descriptive stats, means mean, standard deviation, were computed. And for the relationship check, Pearson coefficient correlation was applied. The descriptive stats showed mean and standard deviation of aggression stands to be 11.35 and 3.247. Mean and standard deviation of locus of control is 10.75 and 3.040. Group cohesion have 4 subvariables. The mean and standard deviation of IAGT, that is individual attraction to group task, stands at 24.40 and 7.679. Mean and standard deviation of individual attraction to group social stands at 31.52 and 8.911. Mean and standard deviation of group individual task stands at 29.88 and 8.525, whereas mean and standard deviation of group integration social stands at 21.52 and 7.287. The coefficient correlation result shows significant difference between individual attraction, group task, and aggression, which stands at 1.05, and the level of significance was checked at 0.05. Individual attraction, group task, and locus of control were also significant at 0.099. So as the significant relationship were found between individual attraction to the group social and locus of control, at 0.05 level. Group integration task and locus of control had also significant relation, which was also significant at 0.05 level, and the group integration social and locus of control was also significant. Now, no significant relationship were found between IAGS and aggression, GIT and aggression, GIS and locus of control, as well as locus of control and aggression. Now, discussion. Significant relationship were found between the group cohesion variables and the locus of control. So, and the mean value showed that higher aggression in football players in comparison to other game mentioned, and handball players tends to have better locus of control as they have low score in comparison to other game players, which shows inclined towards internal locus of control. And as per the mean value, volleyball players have higher IAGT with 25.77. Volleyball players have high IAGS with 32.92, and handball have high GIT with 31.05. Football have high GIS with 22.24. Research conducted previously by R. Delhi in 1987 asserted that people scored internally were less satisfied with the teammates than those who scored externally, and cohesiveness was significantly related to the externally oriented people depicted to have stronger relationship between cohesiveness and teammates than that to internally oriented counterparts. Now these are the same conclusions that we found in the results, and these results will help in develop the suitable environment for the athlete in terms of group cohesion and giving better sense of belongingness to the team, which will help in providing satisfaction and ultimately to the better performance. Now here are the references. Thanking you. Thank you so much for the patience listening. Thank you.
Thank you for your presentation, ma'am. We'll go ahead with the next presenter for the day. I will now call upon Shika. We have.
Yes, sir.
Please share the presentation. I request Preeti Tyagi to stop the share screen. Yeah, thank you. Shika, please share your presentation. Thank you, ma'am. Please start the presentation.
Very good afternoon to everyone. Myself, Shikha, and my presentation topic is VANET, a survey on emergence, challenges, and applications. So this is the outline of my presentation. So let's come to the introduction part. Vehicular ad hoc network, which is commonly known as VANET, is a subform of MANET, and here vehicles act as a mobile node. VANET makes transportation system more intelligent. There are transmission capabilities in each vehicle, and they are connected to each other to form a network. The communication in VANET can be done via two nodes, that is vehicle to vehicle and vehicle to infrastructure. In VANET, network packet is forwarded to a destination by choosing a vehicle which is geographically closest to the destination. This is the systematic representation of VANET. Here it can be seen that vehicles are interacting with each other and with the roadside unit. These are the basic components of VANET. Onboard unit. It is a device which is inside the vehicle which processes the data collected from various sensors which are inside the cars and give conditions of the vehicles, which is responsible for communication with outside network. Roadside unit, these are infrastructure for communication between the cars for sharing and information from various vehicles. It includes computer controlled devices and radio transceivers for message exchange, and it supports the multi-hop communication which uses the standard DSRC dedicated short range communication protocol, and the range is about 1000 meters. In VANET, communication is done through wireless access for vehicular environment, and the sensors or wireless devices can form a VANET network which resides on the top of the devices. This is another diagram of VANET infrastructure. Here it can be seen through red dotted line that vehicles are interacting with each other And blue dotted line shows vehicle to roadside communication, and green dotted line shows the inter-roadside communication. Routing in VANET can be done via two methods: proactive. In proactive routing protocols, each node maintains and updates one or more tables that contain routing information to other nodes. The information in these tables is consistently updated so as to keep routing information consistent and updated as the network status changes. In reactive protocol is an on-demand routing protocol. There is no need for the nodes in the network to keep routing information. Wherever a node needs to send data to a destination, a route generation mechanism will create a route. Based on the current network situation, the route will be cancelled when the transaction is done. This is the literature review. I have put some few of these. The first author work is shown here. Literature survey about various types of attacks, their presentative measures, types of attackers, and some existing security solution for attacks in VANET. The second author's work exhibits that this arterial travel times by probability distribution and define 4 travel time states for through vehicles. The third author represents vehicle accident detection and alert system with SMS to the user defined mobile numbers. The GPS tracking and GSM alert based algorithm is designed and implemented with LPC 2148 MCU in embedded system domain. These are the characteristics of VANET system. The first one is high mobility. In VANET, nodes move with a high speed, therefore it's hard to locate the vehicle to provide security for node privacy. The second one is rapid changing network topology. Due to rapidly changing topology, it's hard to find any kind of misbehavior in the network. The third one is time critical. Within time interval, information in VANET should be sent to accurate nodes so that node could make a decision and execute action. There are some security issues in VANETs. The first one is authentication. It makes sure that real client creates the message. The second one is accessibility. It makes sure that data should only be accessible to the real client. The third one is information verification. Any standard confirmation from claiming information is necessary. Privacy, there have to be a guarantee of maintaining privacy of users' messages against unauthorized users. The last one is reliability. It is basic requirement of users which ensures the reliable transmission of message. There are some kind of attacks in VANET. I have mentioned very few of them. The first one is network attacks. In this, denial of service is a kind of network attack. This attack is done to jam the network by sending the large number of unusable messages. The second one is Sybil attack. In this, one single node has a control on multiple nodes and claims no number of identities. The third one is node impersonation attack. All the automobiles in networks have specific recognition. It turns into important while an mishappening or accident occurs. In this attack, acts real user and shows that message is originated by it. Attacker is able to alter the message in this. The second one is application attack, and the third one is timing attack. So by taking care of all these issues, we can implement a VANET network in some applications like security applications, efficiency applications, comfort applications, interactive entertainment, and urban sensing. These are some of the references which I have taken in this paper. Thank you.
Thank you, ma'am, for your presentation. Good efforts by you. Thank you. We will now go ahead with the next presenter for the day. I call upon Amit Shirkande. Do we have
excuse
Amit?
me, sir.
Yes, ma'am.
Sir, actually, before this presentation, we were scheduled, like Vijay Gaikwad was the author.
Yes, yes. I'm planning to, we have 3 more Vijay Gaikwad authors, so I wanted to continue all the 3 authors at once.
Okay, okay, sir.
Yeah. I call upon Amit Shirkande. Do we have Amit Shirkande? Or do we have Amit Shirkande? Okay. Do we have, yeah, Peter, can you, your MA Peter, is your presentation fine now?
Yes, sir. I'm here.
Yeah, please share your presentation now.
Okay, sir. Yes, sir. This is my presentation.
Please go ahead. Please go ahead. Thank you.
Yes, my research topic is effects on stone dust on lime stabilized granular materials, granular soil. I'm going to check the properties of lime stabilized granular soil when you add the stone dust. So this is introduction on a flexible pavement. As we know, flexible pavement or highway pavement is a structure consisting of number of layers, which are surface cores, binder cores, base cores, and other layers. And the primary function of the pavement is to distribute the axial loads to the soil subgrade without failure. So again, this is introduction regarding the stabilization, because the research paper is based on the stabilization process, which I'm adding the soil plus lime with 20% and other proportions of stone dust from 5 to 30%. So this is just an introduction of stabilization, how it is being defined, the modern technique of improving physical and chemical properties of soil. Because the main purpose of the stabilization is to improve the properties of soil by adding the binder, like lime, cement, stone dust, and other binders. As I told you before, that I'm going to check the pavement performance. Pavement performance based on these 4 criteria, which are strength, resilient modulus, fracture and fatigue, and the durability. So and I'm going to check only on the strength of the pavement by stabilizing the soil with lime and the stone dust. And this is my literature review. As it can see, I've reviewed some literatures in order to strengthen my research. And this is a gap in existing literature. Less work has been done in the analysis of native granular materials, because the soil which I was used is the native local available materials in the construction corridor. So the less work done has been done on the analysis of these native granular materials. Also, less work has been done on the assessing native granular materials locally available along construction corridor, because we are used to use the borrow pits material and importing to the construction corridor for stabilization. But this research paper has analyzed the locally available materials, so that after stabilization, we can see the properties has improved. The objectives are to evaluate the properties of native granular material before stabilization, to stabilize the native granular materials and modify the soil to be used for sub-base materials in flexible pavement, to evaluate the properties of stabilized granular materials, and then determine or to curtail the optimum stone dust content, which will be provide high CBR and the uses. These are the methodologies: sampling of granular materials and lime, study the properties of granular material, mixing of lime, stabilized soil with these proportions of stone dust, conducting the tests after stone dust treated soil, analyzing the stabilized materials properties. And these are tests which was done for the enhancing the research. So these are the properties of granular material before stabilization. You can see the optimum moisture content of the soil was 13.65, but maximum dry density of the soil was 1.857 gram per cubic centimeter. And the soaked CBR was 4.5. Liquid limit, Atterberg limits, you can see plasticity index is 22%. But for the grain size distribution, I used unified soil classification, which is clay gravel. So this is the particle size distribution curve, as you can see, of coefficient of uniformity and the coefficient of curvature has been determined, which is within the specification, and the particle size distribution was well graded gravel based on these criteria. This is a particle size distribution curve for stone dust. So this is a physical and index properties of soil treated with lime, but this is the properties of soil treated with lime on the stone dust. As you can see in the previous slide, that after treating with lime, the properties of soil has been improved to some extent, but with increasing the stone dust, the properties, index properties of soil has been improved much. As you can see, at 10, the plasticity index was almost 7.1. But after treating 10% of lime with 30% of stone dust, the plasticity index was reduced to 4.6, which is within the limit of using these materials for highway design, for highway construction. So this is the variation of optimal moisture content and the maximum dry density with the increase in lime content. As you can see, after increasing the lime content at 10%, the optimal moisture content was increased, but the maximum dry density was decreased. This is due to the fact that after mixing soil with lime, the flocculation process starts, and then come to this result that the maximum dry density decreased and the optimal moisture content increased. But when you add a stone dust on this stabilized lime at 10% lime, you see at 30 dust plus 10%, it's here. You can see the optimal moisture content was decreased to 12 point something, and the maximum dry density was increased. So with the increase in stone dust, we increase the strength and we decrease the optimum moisture content, which results to the increase in strength. So this is the variation of maximum dry density as explained before. This is stone dust and this is for lime only. The same as for optimal moisture content. As you increase the stone dust, the optimal moisture content decreased, but as you increase the lime, the optimal moisture content increased. This is a variation in CBR. When soil treated with lime only, the CBR was reached to 22.4. But when you add the stone dust, the CBR increases up to 42.6. So the increase in stone dust improves the strength much more than use on lime. So this is uses. When lime used only, the uses was 3.2. But when you add stone dust, the uses was increased up to 4.76. Which again showed when you add dust means the strength of the material increases. So this is a discussion of results, as I explained before, that if the addition of lime on these materials, the liquid limit slightly decreases, as well as the plasticity index compared with the addition of stone. So you can see here that plasticity index was decreased from 7.1 to 4.2. This 7.1 the plasticity index was decreased when 10% of lime was added. But after adding 30% of stone dust, the plasticity index exhibits to decrease more up to 4.2 when at 10% lime and 30% stone dust. So as well as maximum dry density and the optimum moisture content. As you can see, the maximum dry density, when lime was used, maximum dry density decreases from 1.8745 to 1.814. But when stone dust was added, the MDD was increased from 1.878 to 1.931. So it shows how much the stone dust improves the strength of the material. Let's go to the conclusion. So according to basing on the discussion I made above, you can see for the materials to be used in highways, according to IRC 3712, the PI should be less than 7%. So in my research, I found that when you add up to 30% stone dust plus 10% lime, the PI was 4.2%, which means that for the materials, at 30% stone dust and the 10% lime, it's enough for the material to be used in the highway, especially in the highways, expressways, and so forth, so on. So it's better to use the locally available materials rather than importing materials from bore pits, which is far away from the construction corridor, which will attribute to the cost of the construction project. These are my references.
Thank you for your presentation.
Thank you.
Good efforts and nice results, actually. Good compilation and a good efforts which are put towards the conference. Nice. So, well, now let us go ahead with the next presentation for the day, as we have very less time. We are exceeding the time limit. Right. We will now call upon the next presenter. So I know we have three presenters of Vijay Gaikwad, I believe Dr. Vijay Gaikwad. So Sahil, Rishabh, and right. So they can take it up one after the other and restrict your time for maximum of 5 minutes and come to the conclusions. Discuss about the results and conclusions. Thank you. Sahil, are you there?
So actually, those are two different groups.
Okay. Are they here, those two groups?
Like Sahil is from my group, which is Smart Flood Management.
Okay,
and
please.
Rishabh has...
Yeah, you can present behalf of the team.
Yes, sir. So is my screen visible?
Yes.
Yeah, Nikita?
Yeah. So good afternoon, everyone. My name is Nikita Shatoy, second year CS bachelor student in Vishwakarma Institute of Technology, Pune. The other co-authors are Shreya Patil, Soham Shirsat, and Sahil Darmia. So our topic for today is Smart Flood Management System using IoT. Now let's talk about the abstract of this paper. This paper describes the creation of an automated flood surveillance system that makes use of the Blink platform as a data transfer medium. So now to construct this configuration, one Arduino Uno R3 development board was connected to the Blink program, iOS or Android. The first Arduino Uno R3 acts as the area, while the second serves as the control unit. Now the transmitter unit, which consists of a first Arduino Uno R3 and an ultrasonic sensor, this will be used to monitor water levels and provide warnings during floods. The data ultrasonic sensors will be then wirelessly sent to the Blink application. The data is collected in real time and kept in a separate database for later use. The data will be then forwarded to a second Arduino Uno R3 via Blink Bridge and which will be activated, and the LEDs, and alert the person in charge of the control unit. So access to the system between the first and second Arduino Uno R3s can be performed in less than or more than 50 meters according to the findings. The system is effective according to the findings when the data acquired by the ultrasonic sensor is shown on the Blink app and the LEDs are active. So the result indicated that the model is capable of dealing with the flood situation in the impacted area. So the introduction for this is that flooding may have devastating economic consequences for a town. This is due, among other things, and interruption to communication towers, power plants, roadways, and bridges. This effectively halts any business activity in the region. So long after the floodways have retreated, major flooding typically creates disruption and dysfunction in daily life. So tsunamis are one of India's most common natural disasters. The Indian subcontinent has a distinct geological structure that makes certain sections of the national susceptible to flooding. So in the north, the snow-capped Himalayas contain one of the world's biggest glaciers, which feed a number of perennial rivers. Now, these rivers join together to form a vast plain that is home to millions of Indians. Flooding is mostly caused by low-pressure zones in Punjab, Gujarat, Rajasthan, and Jammu and Kashmir. Flooding has occurred in Odisha and Andhra Pradesh as a result of the monsoon depression. Floods occur on a regular basis in today's big cities. Next slide. So this flood is caused by a poorly managed drainage and sewer system, which becomes blocked as a result of irresponsible water disposal in drains and inadequate maintenance by relevant organizations. So from 1915 to 2015, India saw 649 natural disasters. Floods were responsible for 302 of the 450 catastrophes, with 3 floods occurring on average per year. This accounted for over 47% of all disasters in India during the previous century.
Nikita, can you come to the results and the actual work rather than introduction and focus on the work?
Yes, sir. So now there's the methodology and there will be the results.
Yes, sir. So myself, Shreya Patil, and I'm a second year's computer science student in Vishwakarma Institute of Technology. I'll be elaborating briefly on the methodology. So the components we have used here are various sensors, which include the DHT11, which is the humidity and temperature sensor. We have also used ultrasonic sensor, which is the most important sensor in this project, since we are going to calculate the different water levels. And the other sensor that has been used is the tilt sensor, which will be giving us an idea of how the wave positions are changing. So this project can be implemented on dams when it comes to like a wider implementation of the project, or even at homes where you would like to monitor the water levels in tanks. So moving on to the components that we have used. So ultrasonic sensor, which I said was one of the most important. So it can measure range from 2 centimeters to 400 centimeters. This is going to use sonar waves, like sonar radiation, to measure the level of water. So we have different water levels in this case. In the sensor, there's one transmitter, which is the emitter, and one is receiver. And these are the 4 pins which are available on the sensor, which is VCC, which is then there's trig, echo, and ground. So this would be the formula for calculation, and we are dividing it by 2, since the distance calculated would be the emitted one and the received one. Then there's ball tilt sensor. This is a capacitive sensor. Now, why are we using a capacitive sensor and not a normal tilt sensor? So when it comes to capacitive sensors, these are unaffected by other environmental changes like humidity or temperature. So basically it increases accuracy of your readings, accuracy of what is being measured. And they use electrodes so that as the capacitance decreases, when the ball moves away from the electrodes, the change in the position is measured. The next is DHT11. This is being used to measure the temperature and humidity around, since we have a flood monitoring system, and all these parameters, all the environmental parameters will be playing an important role in detection of the flood. This is the circuit architecture of our proposed system. So this was made on Tinkercad as we assembled our project there. This is the flow chart, which is we start with establishing connection between Arduino and the network, read sensor values. So we had given a threshold value of 50. If it exceeds, then it turns the LEDs on, and simultaneously it will keep turning on LEDs as the level of water increases. And if no, then it will stop. Moving on to the results.
Yeah, so talking about the results, so the smart flood management system detects floods by employing 3 sensors, which we have just talked about. First is the ultrasonic sensor, second is the tilt sensor, and third was the humidity sensor. The ultrasonic sensor detected and monitored the levels of water by releasing the ultrasonic waves. The distance between the surface and the sensor was calculated by recording time taken and calculating the distance appropriately. The tilt sensor analyzed the stability of the water by using a ball within the sensor. And lastly, the humidity sensor helped in measuring the moisture in the atmosphere by sensing changes in ambient air that modify the electric current or temperature. A humidity sensor operates on 3 primary principles: capacitive, resistive, and thermal. So the data from all of these sensors would be collected in order to forecast a flooding occurrence in that specific location. LED lights would be used to display the output of all the 3 sensors. And depending on the output from the sensors, each LED lights up in a certain order. Now, the event of a flood, all LED lights would illuminate to inform everyone, and an SMS would be sent to alert. Now, as there's a visual representation too. Next slide. So this was the readings. These are the readings from the serial monitor that we got. So distance in centimeters 20. So this was when, so we used our hand for the demonstration. So this was when the hand was kept the farthest away. And as we got it near the ultrasonic sensor, the centimeter or the distance kept reducing. So 16, 15, 12, 11, 9, 11, 8, 8, 6, 7, 18, 19. Slide. So this was the model that we created. So the ultrasonic sensor is on the left side of the flap. We have the LED lights. The blue one will indicate the lowest level of water rise, and the red will indicate a flood, basically the highest level of water rise. We also had a buzzer, and a tilt sensor is attached outside of the water, and it's kept in a plastic bag so that we could put it in the water. Next slide. So yes, conclusion, this paper focuses on a simple yet reliable, cost-effective smart flood management system. The future scope was that the blink system was not installed in the model. So we could still work on that and make an SMS alert system and create an application for alerts. That is it. These are the references. We referred 15 to 20 papers.
Thank you for your presentation. Nice efforts being in the first year and second year of your engineering. Good efforts.
Thank you.
Well, let me now quickly call the next participant. Do we have the next participant over here? Vijay Gaikwad team. That is Rishabh.
Yes, sir.
Uncle team.
Yes, sir. Yes, sir.
Please share your presentation and restrict it maximum to 5 to 6 minutes of presentation. Thank you.
Sure, sir.
Hello. Am I audible?
Yes, you are audible.
Okay, so
is the presentation visible? Is the presentation visible?
Yes, it is, Rishabh. Yeah.
Okay. All right. Go ahead.
Okay, so our project for today was Smart Gear for Blind. So basically, we have developed this project under our guide, Dr. Vijay Gaikwad, and we are the co-authors, Rishabh Khandelwal, Sankalp Chodia, Rajat Tharne, Shravani Navalkar, and Shritish Joshi. We are the students of second year Computer Engineering Department and Vishwakarma Institute of Technology. So moving forward, without wasting any time. So these are the tables of content which we are going to cover into our presentation. So we'll start with the introduction, objective, methodology, results, and conclusions. So yeah, so basically the main introduction. So basically in India, there are like various visually impaired population. So this population usually use walking sticks to navigate around. So basically for them, a very convenient and easy to use would be a smart gear device which we developed. And even in schools nowadays, there are certain areas where visually impaired student cannot go. It would be dangerous for him to go. So basically, focusing on these problems, we have come up with a smart gear for those people. And yeah, next slide. So basically, we have developed a smart gear, which is a wearable device which can be worn on the hands of the visually impaired guy, and they would be able to navigate through it without any hesitation. So we have used ultrasonic sensors to like detect the nearest obstacles, and they would be alerted based on those obstacles, how far is it and how close it is. So, and the other part of it, our project is to like monitor the movements of visually impaired students if they enter into some danger area. So a notification would be generated likewise. So moving forward. So these are a few basic components. So there are two parts of our project. One is the smart gear, which is worn on the hand of the visually impaired student. So it would be an ultrasonic sensor, an Arduino Nano, a battery, a motor, an LED, and a buzzer. So a motor acts here as a vibration sensor. So that's one thing. And the RFID system, we are using Node MCU and RFID reader and tags. So basically, this is a very basic workflow for our project. So, and visually impaired student would go and he would detect an object, and then it would be given a warning to the visually impaired student that object is nearby. So, like next slide. So basically, the technological specification. So basically, we tested our model with a visually impaired guy, and he was able to tell. So we tested all this range of, like, we have written RFID operates at this range and ultrasonic operates at this range. So basically these range are basically taken from the convenience of the visually impaired student. So for the ultrasonic sensor, it detects from distance from 10 centimeter to 50 centimeter, and RFID also from 10 centimeter to 50 centimeter. And we have also used Arduino Nano, which supports IEEE 802.11b, IEEE 802.11.g, and 11.n. So its range is for 400 meters. So basically, these are the technological specifications. Now moving forward. Okay, so this is the model of our project. So it is divided into two parts. So the first is a smart gear part. So this is the smart gear part is worn on the hand of the visually impaired person. So it has consist of an Arduino Nano, which takes the power supply from the battery which is attached to it, and then it takes the input from the ultrasonic sensor of how far the obstacle would be. So it takes the input, and the Arduino Nano is programmed in such a way it would give us the warning based on the LEDs and the buzzer and the motor. So how far is the object is the intensity of the buzzer is depending upon that, the intensity of buzzer and the motor as well. So motor act as a vibrator there, and it because buzzer, there could be few chances that the person who is cannot see can also not hear as well. So we have also integrated a vibrator in it. So basically the buzzer, so it is for all purposes. So that's why we have included a motor and the buzzer. And we have also have an RFID tag. So each RFID tag could be a unique RFID tag for various kind of people. So now let's say there is a restricted area in a particular school, and that school there is a door, and you can't the visually impaired student cannot go because it's dangerous for them. So there on the door handle, we would integrate this RFID system. So the RFID reader is connected to the Node MCU, and the Node MCU. So if an RFID tag comes near the RFID reader and it is detected, so a particular RFID is made for a particular person. So they would be reflected upon our website from the Node MCU that this particular person has entered into the restricted area. You can monitor this people everywhere. So we have a website created where you can monitor that this person has entered into the restricted area. So this was the model.
Now, I am Rishabh Khandelwal, one of the co-authors. And good afternoon, everyone. So the cost of our smart gear, that is the first part of the project, it comes up to around 600 rupees. So we are trying to create a very cheap and economical system, basically, for the blind, where within 600 rupees of investment, they can actually replace a stick or a walking dog, which would roughly cost them a lot of amount. A dog, training them, and then helping them to guide would be a huge cost, and we can replace such things in just 600 rupees. And for schools and other places that want to integrate the RFID system, we've got the cost down to 1,000 rupees, where we were able to build the model within this range with the smart gear. This is the implemented project, where this is the first part of it. As you can see, an Arduino Nano here has been used. The buzzer has been mounted on it. This is the motor, and this is the ultrasonic sensor. All of this has been attached to a battery so that it can have constant power supply. And these have been mounted on a basic hand band so that it can be easily worn. Now, this is the RFID reader and tag model. Now, this part, the RFID reader and the node MCU would be placed on a handle. And this RFID card that is there, it would be detected at a range that was mentioned from 10 to 50 centimeters, so that we can monitor the person who is basically visually impaired. These are the results that we have obtained. Now, when the actual distance was around 10 centimeters, our ultrasonic sensor was giving a 10.1 centimeter reading on our serial monitor. And we can see that the percentage error is just 1%. And the errors of percentage range from 0.4% to 1%, which is really low, and it would not affect someone, which shows that our system has been quite efficient to detect an object that is at a distance. Now, this is an implemented result where, as you can see, when the person comes close to the object, there is a buzz that comes. The person also feels a vibration depending on the distance, which tells them that this is the kind of distance that are in. If the distance is very close to the object, the buzzer that will give a feel on the hand will be very high. And on the other hand, the sound will also increase comparatively. Now, coming to the conclusion of our project. So this is basically to assist the visually impaired by sensing all the kinds of obstacles that would be there in their path, as we saw earlier in the video. This is highly useful for monitoring the areas that would be restricted for visually impaired students as well, with the help of an RFID reader. And this would help keeping track of students. So in case of emergencies where we have to evacuate these students in a normal school, probably, we should be able to locate them very easily. And through this, once these are implemented on school doors and other places, it would be very easy to actually pinpoint to where help is required during an evacuation or any kind of an emergency, so that no time is wasted and lives can also be saved through that. The future scope of our project would be that with an integration of a GPS, probably we could closely monitor the person. Right now, we can just monitor that these, we'll be only able to monitor the places where these readers are available. But with the help of GPS, this person would never be lost in as such. The additional future scope is that, you can put it on all doors of classes so that we can actually have a count of the number of students also. And the final future scope that we see is that the integration of a guidance system with the help of vibration sensors. So if I just put in a basic map kind of a thing where I put location A, I have to travel from location A to location B, I will be able to travel with the help of these ultrasonic sensor and the vibration motor, giving me an indication on which side I have to be moved. And for our presentation, we've referred to multiple papers. These are the 4 major important ones that we thought of mentioning. And thank you so much.
Thank you for your presentation. It was a good effort, actually. Very nice project. So, yeah, nice efforts. Thank you.
Thank you, sir.
I will call upon the last presentation. We will now call upon the last presentation for the day, Smart Alarm Clock.
Yes, yeah.
Yeah, do we have the team? Yeah, please go ahead. Last presentation.
Sure. Yeah, is it visible?
Hello, can anyone acknowledge if the screen is visible?
Yeah, it's visible.
Okay, so hello.
Hello.
Yeah.
Anajisikia sana. Oh, kwa asubuhi napompigia simu nimpigie Mayuni niende nikafate. Nani? Masoda sana. Wewe anaanzaje kwa mfano? Itakuwa kweli.
Am I audible? Do we have team Aryan Shinde and Vijay Gaikwad over here?
Yes, sir. Yes, sir.
Yeah. We are waiting for you to share the screen. And,
Okay, sir. I'm sharing.
Yeah, please go ahead. Please go ahead. I had some technical issues. I couldn't able to turn on my video. Please go ahead and start, and please try to complete it in another 5 minutes so that we can end the session. Come to the thing. Thank you.
Okay, sir. Is my screen visible?
Yeah. Hello. Sorry, I'm back.
Yes, Ravi.
Yeah. So, Vishwa, sorry, I just got a call. I just disconnected, and then I'm here in the campus. Yeah. So,
Hello.
to brief about my institution,
Am I
Acharya
audible?
Pathashala, a group of institution. I believe it's one of the oldest
Yeah,
institutions.
is my
You would have
screen
heard
visible?
about it. Like in 1935, the organization actually started. So, if you have heard about it, it's in Baswangudi, Ganesh. You're from Bangalore?
I was based out of Chennai. I've been in Bangalore for 7 months now.
Okay. So because people would have heard Ganesh Utsav in Bangalore famous and all. So it's like our APS grounds only it will be usually conducted. So it's one of the oldest organization, 1987 years old trust and government aided trust basically. I mean, college, there are many 7 institutions which are government aided and very old organization. So we have courses from BCA, BCom, BBA, all such.
Hello. I think I lost my internet connection. Can you guys hear me?
Yeah, you are audible.
Was I audible until
Yeah.
when? I don't know. I just got disconnected. Yeah. Was the introduction part covered while I was disconnected?
No. We could just see your
No, no.
first slide.
You just started.
Okay, I'll start from the start. Cool. So for our conference, this is a topic which is a smart alarm clock, and this is our author and our co-authors, and we are from VIT Pune. And the agenda for today's conference meet is our introduction, problem statement, methodology that we implemented, system and circuit design, results, images, conclusions, and references. So for introduction, what we have actually made in our project. So as we know, there are elderlies at our home that need assist, and they are not much educated about the connected devices they have around them, and are much more complicated for them to make a connection to their loved ones, to inform that how they feel at home. Do they feel safe? Do they feel scared? What's happening around them? And also they don't go much outside, so they don't have an idea of what's the temperature and humidity around them, and also a way of showing current time and date for them. So this is all we have integrated into our system. And our problem statement, as I discussed, we have elderlies at our home and they need assist, and yeah, we have made for them. What is the methodology that we followed? So we have made an IoT based project where we added Node MCU as a primary microcontroller, and we set an alarm through it, and also we get SMS using Blink app, and also email through it. And the data that we get through the temperature is sent to the ThinkSpeak cloud, and such that all the data are pretty much managed into a perfect graph and get you an idea of what can be predicted further. And the system design, as said, the Node MCU has been using as the primary microcontroller, along with the RTC module, which is a real-time clock module, which gives real-time date and time, and also the buzzer as per the as it's an alarm clock. It gives you an alarming buzzer when a certain time has been clicked. This is the circuit design. As you can see on the left hand side to the bottom left, it's a node MCU used, and to the coming from top right, the buzzer, panic button, and the DHT22 sensor, and the below one is the RTC clock module. The to your top left is an LED matrix to show the date and time. And this is the result just to show how accurate we have got the reading in degrees Celsius and Fahrenheit of 37 degrees. It was as accurate as found on the Google Maps and Google Weather apps. And the temperature and time graph, as we said, the data that we have gotten through the temperature sensor has been pushed through the ThinkSpeak cloud, and this is the graph that we have gotten of the certain temperature at a certain time. And this is was calculated as the sensor was started, and it was off abruptly. So you can see it has a downfall into the graph. And these two equations were used to calculate the voltage that was required as per the temperature and the humidity. The left one is the temperature and the right one is the humidity sensor equation. The result, this is the result that we gotten. It is the voltage that it needs as per the temperature that we have currently. So the minimum supply voltage versus temperature graph has been gotten as a result as per the temperature sensor. And this is the images. To the left hand side, we have a breadboard connected with the node MCU and all the wirings with the panic button to the center of it. And the right is the buzzer and RTC clock module. And to the right hand side, we have a screenshot of the mobile application where a blink app notification is visible and also an email to the same. which says a panic button has been pressed. So whenever the button has been pressed, email and notification has been sent to the house owner using Blink app. And to the conclusion part, so we have successfully made this model and we have used a DIY approach to help our elderlies at our home, and it has been working flawlessly and been using onto day-to-day life, and we suggest to make it further more and scalable product. And this is just to start off. And these are the references that we use for our paper, 12 papers. And thank you, and any question will be appreciated. This is the paper that you submitted.
So you can follow up with the same email which you are corresponding. You will be receiving all the updates at earliest, right? We will make sure all the details have been received to you, right? So any other things or you want to connect regarding, I can also share my personal email. You can note it down. So I can share you my personal email. You can just connect with me there. Right, Scopus index and other things. No, we are a Google index based organization. For Scopus index and all, you can make a request, Peter, so that it can be taken forward as through us. We have Scopus index tie-ups. We can initiate it, so you can we can take these questions offline. Indeed, again for support and other things, we will obviously help this out. So that's it. Thank you, everyone. We have I've just taken the screenshot. So any doubts are there? Anything you would like to connect? Right? Please mail me. I'll reply back. Right? We will get in touch. And thanks a lot for your kind patience. And hope any queries or anything anyone has?
Sir, where are we supposed to share the presentation?
Sorry, ma'am.
Where are we supposed to share the presentation?
Presentation, huh?
Yeah.
You will be getting the, you want to share, I didn't get you. I didn't get your question.
I guess we had to submit the presentation that we...
Yeah, you can mail the presentation to the same email address, ma'am. Like your paper has been selected, right? For the same email address, I request you to mail so that they will be keeping a track of all the presentation.
Okay, okay, thank you.
Yeah. So if any other questions are there, please feel free to ask. Hello, sir.
Hello, how are you, sir?
Sir, doing good, sir. How are you, sir?
I'm fine. My question is just related to Scopus Index. I would like to get my paper published in a Scopus Index journal.
Sure, sir. Sir, please mail me to that personal email address. We will take it up personally, and then we'll make it sure any, like, we'll do it to, like, you know, for all the second level plagiarism and other things, we'll push it up and all. So we will connect you separately for that, sir.
Okay. Do you publish in Web of Science also?
This is already in Web of Science. All these are Web of Science conferences only.
Okay.
Yeah.
Thank you. Thank you.
Thank you, sir. Thank you. Well, anything you would like to connect, please feel free to mail. If not, we are good to end the session, I believe. Thank you everyone for your kind patience. It was a wonderful to have and present all this screenshot and other things which has been taken. We will mail you. You can mail us back at any point of time, and also recording. Also, you can have a request. Thank you.
Thank you, sir.
Yeah.